Okay, problem two is different from problem one in terms of the type of the duration or the nature of the durations of the activities. So while in problem one, the durations were certain, deterministic, here they are probabilistic. But luckily, they are not unknown, right? Probabilistic does not mean unknown. Probabilistic means that they can vary. And we are given here a table showing that these activities, okay, the activities that make the project, and the P&D is also given to us, so it's making our life easier in this problem. And for every activity you can see that we're given the optimistic, the probable time, and the pessimistic. As you learned before, pessimistic is the longest time an activity can take, while optimistic it's the opposite, it's the shortest time, and probable, this what have happened in the past in most of the time. That's why it's called the most probable or simply probable. Okay, and we are given also the precedence relationship, but obviously in this case we don't need it because the P&D is already given to us. Okay, but if you want to practice on your own how to create this P&D yourself, I strongly suggest you to do it because you have the precedence relationship. Anyway, now the question is find the critical path, find its expected duration, and the standard deviation of this duration, the duration of the critical path. Okay, so how to find the critical path? So far, we are doing exactly what we did before. To find the critical path, all what we have to do is to list all the paths, then sum up the durations of the activities in each path to find the path duration, but sum up which activity duration, because as we said before, for every activity we have 3 time estimates: in optimistic, probable, and pessimistic. So what do we do? How to find a path duration? What do we do is for every activity we find the expected duration, right? And then we sum up the expected durations of the activities, and this will give us the expected duration of the path. Okay, so remember how to find from the 3 time estimates the expected duration. It's equal to TO. Okay, so TE, you will have the formula, so this is not a problem for you. It's equal to T optimistic plus, because the probable happened the most, so we multiply that by Tm, so most probable, plus the pessimistic, and we divide the whole thing by 6, right? Because it's a weighted average, where we're given a weight of 1 here, 4, and 1 also. Okay, this is TP, so it's 1 times TP. So that's why the sum of the weights is 6. Anyway, so I have added here a column where I calculated the expected duration for every activity. For example, 10.5, how did we get that? This is equal to 5 plus 4 times 11, that's 44, plus 5, 49, plus 14, so that's 59, and 63 divided by 6, you will get 10.5. And for activity B, again, it's the same thing. You simply apply the equation. So it's 3 plus 9, that's 12, plus 4 times 3, 12, plus 12, 24. 24 divided by 6, that's 4. All right, so this is how you get it. Also, I strongly advise you to practice finding these on your own. All right, now what do we have to do? We need to find the critical path. Now, once we did what I just did in here, the procedure will be exactly the same as we did before. So first I identify the path, and I always do that. I scan my P&D from top to bottom. So that will give me the first path to be ADG. Okay, this is the path that's happening on the top of my P&D. Okay, and I simply sum up the durations of these activities, okay, which is so I'm looking at path ADG. Okay, first let me show it to you here, ADG. So we wrote it here, and ADG, I sum up the durations, so 10.5 and then 5, so that's 15.5, and then G4, so that's 19.5, and here we go. Second path, what do you think? Yes, also I like to be systematic. A, I cannot go anymore, so I will have to shift to B. B, I go up. You remember I like to go bottom to top. A, so it's B, D, and G. And here we go, B, D, G. How to find? You simply also sum up the durations or the expected durations of BDG. So that's 4 plus 5 again, so that's 9. And G is 4, so that's 30. Now, path BEG, we do the same and we get the duration or the expected duration to be 14.5. And finally, the path CFH, it has a duration of 22.5. So you notice that this is the longest path, which makes this path to be our critical path, right? So this is our critical path. And this is important because you know that to answer a question about the probability of finishing the project within a certain time, what we need to do is to answer the same question about finishing the critical path within that time. And that's why the question on the top was find the expected duration. So we found it, but we also want to find the standard deviation for reasons that we explain, and you are going to see it next why you want the standard deviation. So I want the standard deviation. How can I find the standard deviation for the path? As we learned, we do not sum up the standard deviations of the activities in that path, but what we do, we can sum up the variances of the activities in that path. So to do that, first let me erase these so that you can see the variances that I'm going to find, and I don't have to find the variances of all the activities, right? Because from now on we are interested only in the critical path, which means we are interested only in the critical activities, C, F, and H. So I find the variances here, okay? Okay, let's take an example. How did we find this 1.78 for activity C? What's the variance? The variance is equal to TP. Okay, so sorry, it's the pessimistic, it's TP, so 7, minus TO, 3, so 7 minus 3, that's 4, and squared, right, the variance, it's equal to TP minus the optimistic. We square that difference and we divide by 36. Correct? So that's why the variance for activity C is equal to, sorry, I was here showing you the wrong one. So activity C, that's 14 minus 6, that's 8. 8 squared, that's 64. 64 divided by 36, you get 1.78. And you do this here and you do that here. This why it's 1. Look at this, it's equal to TP, pessimistic, so 9 minus 3, that's 6. 6 squared, 36 over 36, that's 1. That's why we got this 1. Now I can sum up these and find the variance of my critical path. So let's summarize what we are finding for the critical path here. Let me clean it up so that you can read it clearly what I'm doing here, because I really need this information. Okay, that's enough. So for the critical path, we have found the expected duration before. Here we go, we did it here, 22.5. The variance, how do I do the variance for the duration of the critical path? I simply sum up 1 and 1.36 and 1.78, and we get 4.14. But I want the standard deviation. The standard deviation, square root of the variance. And here we go. So we're going to use this and that to answer the question about the probability to finish the project within a certain time. Okay, so now we're going to use these two metrics that we found for the critical path, which are the expected duration of this path and the standard deviation of the duration. Okay, and I put it here on the side so that we can see it when we want to do the calculations. The question is, find the probability that the project is completed within 25 weeks. Okay, now to start, first remember the assumption that we did, otherwise we cannot proceed as follows. That a path duration follows a normal distribution. Why? This will allow us then to use the z-score. Okay, so I will denote x to be the duration of this critical path, right? And so I know the expected value of x and I know its standard deviation. It has a normal distribution, so I can use that notation. Remember, it's normal distributed with a mean now of 22.5 and standard deviation of 2.03. Now, we are using the simplistic form that says that the probability of finishing the project within a certain time, it's equal to the probability of finishing the critical path within a certain time. I told you that this is not the accurate approach, but it's good enough for us. So what we write then that the probability of finishing the project within 25 weeks is the probability that x is less than 25 weeks. Why this is important? Because you see, once you reach this probability statement, you go back to what you have learned in your managerial statistics course, which is very basics, right? That's it. It's all what you have to know about then project management. What comes later, next is simply statistical calculations. So how to find the probability that x is less or equal than 25? I'm going to convert this x into z. So here I'm giving that z is subscript 28, meaning that, sorry, this should be 25. I'm sorry about that. Okay, 25. So which means that I'm finding the value of z corresponding to x equal 25. So I use z equal, remember this equation, x minus mu over sigma. This is how you standardize an x. So this x is 25, the value that we are interested in here, minus the mean divided by the standard deviation. So it's 1.23. So why this is helpful for us? Because now that we found the corresponding value of z that correspond to x is 25, now I can shift this probability statement into a probability statement in z. And here we go. Then to find that, I say that this is equal to p of z less or equal than 1.23. So how did this solve my problem or help me to solve my problem? I now can go back and refer to the z table. Here we go. This is part of the z table that shows part of the z's including 1.23. How do I find that? This is 1.2, but I need 1.23. This column corresponds to 1.20, 21, 22, and 1.23 is the third one. Here we go. So what I can read in the z table is this, that p of z less or equal than 1.23 is 89.07% or 0.8907. So that means that p of x less or equal than 25 is that value. So we answered the question about the completion time of the project itself. Okay, so I hope this was clear for you. This is another time, or this is the same procedure that we also demonstrated in the videos, the lessons videos. And I hope that now you are confident to do it on your own. Thank you.